So hello students, now we go to 12.9. It is the last topics of the chapter 12, okay, limiting reagent. So in this case, we need to determine which of the reactant is the limiting reactants. Normally, for this kind of questions, normally they will provide two known reactants, known amount of reactants, and one unknown of products. Then we need to determine which one is the limiting reagents. Okay, so this is the main idea of the main purpose of this topic, this chapter. Okay, so for example, here you can see theoretically for this equation, there are 2 mole of hydrogen react with 1 mole of oxygen to produce 2 mole of water, right? And then if we suppose, if the question provided, if there is a reaction, there are 2 moles of hydrogens, so and 2 moles of oxygens, so 2 moles, so 2 and 2, and available for reactions. Then after the reaction, suppose there still have 2 mole of water produced, but there is 1 mole of oxygen will be left over, okay, when the reaction completed. Okay, 1 mole of oxygen will be left because we use 2 mole of oxygen, but theoretically we know that 2 mole of hydrogen just react with 1 mole of oxygen, right? So 1 mole is excess, we can say. In this topic, for calculation, the unknown amount of products, we don't use the excess amount of reactants. We always use the limiting reactant, okay, for calculation further. So, okay, not use for the reactant that is excess. So if 2 mole of oxygen, we don't consider this amount, we will consider this amount, okay? Let's see the following example. So in this example, as you can see that it's a reaction of magnesium and nitrogen to produce the magnesium nitride, okay? And then 16 gram of magnesium and we have 8 gram of nitrogen. So means that, can you see that there are 2 known of reactants? One is nitrogen, another is magnesium, right? 2 known. So that we need to firstly determine which one is the limiting reagent. So you can see part A, identify or determine which one is the limiting reagent first, okay? So there's a method, we have 2 methods to solve it. Okay, let's see the right hand side. So we still write down all the information from the questions, the equation, and then the mass, individual mass, and the question finally will ask you to calculate the mass of magnesium nitride, okay? But first of all, we need to finish part A first. Normally, if the mass is provided, then we calculate the number of moles. So for magnesium, we just use mass divided by molar mass, okay? We have learned this equation before, and then we equal to number of moles. So mass divided by molar mass of magnesium, so it's turn out 0.658 mole. And number of moles of nitrogen still use mass divided by molar mass, and then the mole is equal to 0.286 mole. And now we use a strategy to determine which one is a limiting reagent. Okay, now let's see the first method. For the equation, we can see the mole ratio between magnesium and the nitrogen should be 3 to 1, right? The mole ratio, okay? So there's nothing in front of nitrogen, but I'll show it to 1, right? So Mg to N2, actually the mole ratio is 3 to 1 or 3 over 1, that is equal to 3. But let's see, we calculate the real mole ratio by using the number of moles just we obtained. So from Mg over N2, we just use 0.658 divided by 0.286, that actually approximately equal to 2.3. Actually, this number is smaller than 3. Okay, When smaller, so this sign is very important, smaller than 3, so smaller, then means there's some possible insight we can see. Let's see why it turned out 2.3 that less than 3. Maybe the number of mole of magnesium is smaller number, so smaller number divided by a fixed number, then turn out the quotient will be smaller, right? Or on the other hand, if let's see, the number of moles of nitrogen is a denominator, if larger when the numerator is unchanged, when the denominator is larger, then we still got a smaller number, right? So in this case, we can see that the denominator should be larger and the numerator should be smaller. Okay, so that we get a number that's smaller than 3. Okay, so now we can see that if the denominator is larger, that means that the number of mole of nitrogen is larger, is greater amount, that means that nitrogen is in excess and magnesium is the limiting reagent. Then we can solve this problem just by using these strategies. So on the other hand, we can show you another case. If let's see the left hand side, if magnesium to nitrogen is equal to the real count the real moles. Okay, something like 0.658 divided by 0.286, and turn out the answer is 3.3. If just if 3.3 actually is greater than 3, so 3 is the theoretical mole ratio, right? So if equal greater than 3, that means that the numerator should be larger and the denominator also should be smaller. So we just can give a conclusion that Mg is in excess amount because it's a larger amount, excess amount, okay? And N2 should be the limiting reagent, okay? Or limiting reactants, okay? So just opposite. So I hope you understand this case, okay? Just compare the number of moles to the theoretical mole ratio, okay? So in the second method, to determine which one is a limiting reagent, we can see do the same thing at the beginning, like write down the formula according to the question, and then calculate the number of mole respectively. For example, number of mole of magnesium equal to 0.658 mole. Number of moles of nitrogen is equal to 0.286 mole. And after that, let's see. From the equation, the mole ratio is 3 mole of magnesium needs 1 mole of nitrogen, okay? From the equation, you will see that. So 3 mole of magnesium react with 1 mole of nitrogen, okay, or needs 1 mole of nitrogen. Then, theoretically, if you use the number of moles from the questions, that means that 0.68 mole of magnesium from the questions, and it just needs, if the ratio is 3 to 1, it just needs 0.219 mole of nitrogen, okay, in theoretically, because the mole ratio is 3 to 1. Can you see that? It's a 3 to 1, the equation. So that the mole still, you need to make it into 3 to 1. So how can you make it into 3 to 1 when 0.658 is 3? Then 0.219 should be 1. Okay, how do we get the 0.219? We just use 0.658 divided by 3, then we get 0.218. You can use calculator to calculate 0.658 divided by 0.1219. Then the ratio still equal to 3. Okay, then we can compare these two numbers, 0.219 and then 0.286. So in the real case, number of mole of nitrogen actually is 0.219. 0.286 mole, right? Which is greater than 0.219 theoretical. So in real case, that means that nitrogen is in excess because it's larger than the theoretical number of moles. So that means that magnesium is a limiting reagent. Okay, so this is a second strategy that can determine which one is a limiting reagent. Okay. Now we can solve the example in the whole picture. Okay, let's see the following equations here. We just directly write down from the questions and write down all the information from the question: 16 gram, 8 gram, and the unknown is magnesium nitride. And then first step, we need to calculate the number of moles of the reactants respectively. So number of moles of magnesium equal to mass divided by molar mass, so equal to 0.658 mole. And number of moles of nitrogen actually is equal to mass divided by molar mass, still equal to the equation is the same, right? So equal to 0.286 mole. Then we have two approaches to determine which one is the limiting reagent. Okay, so up to you. There are two methods. Some students like use method 1, some students like use method 2. Up to you. Okay, I think both our methods are not really difficult to understand. Okay, for approach 1, let's see. From the equation, the mole ratio is magnesium to nitrogen is 3:1, so it's actually equal to 3. If not 3:1 or 3:2, then you can use calculator to find out the number. And then we use the real mole to compare magnesium to nitrogen, 0.658 divided by 0.286, and turn out the number is around equal to 2.3, which is smaller than 3. So we got a smaller number than the theoretical. So the possible answer may be the amount of nitrogen. The amount of nitrogen may be larger, or the amount of magnesium is smaller. Okay, smaller than that means a limiting reagent. Then larger, then maybe N2 is in excess amount. Okay, so that turn out N2 is in excess because it's a larger amount. Okay, and magnesium is a limiting reagent. Okay, so some of you may know why 0.286 will be larger. Okay, you can imagine that when the denominator is larger, then the quotient should be smaller. Okay, so this is a larger amount. This is mathematics skills. Okay, and then go to the second method. Let's see what happened. 3 mole of magnesium need 1 mole of nitrogen. This is from the equation. And then that means we use the real mole, 0.658 mole, actually just needs 0.219 moles of nitrogen. How do we get 0.219? We just use 0.658 divided by 3. Okay, we want to make sure the mole ratio unchanged. So 0.658 divided by 0.219 actually still equal to 3:1. Okay, so and then we compare the real situation. The number of mole of nitrogen is 0.286. Can you see that? 0.286 is from here. Okay, it's from here. Actually, it's greater than the theoretical number of mole of nitrogen. So that we can claim that nitrogen is in excess amount and magnesium is a limiting reagent. So one is excess amount, another one must be limiting reactant. Okay, remember that. And then we can, after we determine which one is a limiting reagent, then we use the old method. Now we only got one known and one unknown, right? So the known one is magnesium. Okay, the unknown one should be magnesium nitride. Okay, we only got these two. One is known, another one is unknown, because this nitrogen is in excess amount, so we can cross out. We don't need to consider its amount. Okay, then let's see the solution. So Mg to, because we can find out the amount of magnesium nitride, so we use this mole ratio, known divided by unknown, or unknown divided by known, doesn't matter. So Mg divided by Mg3N3 equal to 3/1, because the mole ratio is 3:1. So actually equal to 0.65x divided by x. So we can let the number of mole of magnesium nitride be x, so that we can use this strategy, this box, this equation, right, to solve x. So x actually equal to 0.658 times 1 divided by 3. Okay, we just use a cost method to solve it. So x equal to 0.219 mole. X actually is the number of mole of magnesium nitride. And then the question asks the mass of magnesium nitride. Then we just use number of mole times the molar mass. Okay, just use number of mole times the molar mass, and then we got the answer, 22.1 gram. Okay, so normally this chapter we use the equation frequently, like this equation. Okay, mass divided by molar mass. Okay, this equation very important, and the interconversion of this equation also very important, because when you know the number of mole and then you want to find back the mass, then we use the last one. So number of mole times the molar mass. Molar mass always given, because you can just simply find from the periodic table. You just add up all the relative atomic mass, and then you can find any formula units, molecular mass, or any molecules relative molecular mass. Okay, and then you find out the mass. Okay.